Hi, today we're going to talk about the periodic table and how it was arranged. So the periodic table was arranged around the 1850s by a man by the name of Dmitry Mendeleev. And Dmitry Mendeleev was a Russian scientist who noticed some trends among certain elements. So he placed these elements on this table in a very primitive form of this periodic table. And as you look up and down these columns, they have very similar chemical properties. So this is over 150 years ago, and right now this is the periodic table as it stands today. So there's a couple of things. The elements on the periodic table, commit this to memory, are arranged in order of increasing atomic number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. You always read from left to right, and then down and over, kind of like a typewriter. Now, as we go across a periodic table, this is called a period. Again, a period. In the first period, we have one orbital. Look at the electron configuration for hydrogen, look at it for helium, one orbital. In the second period, we have two orbitals. In the third period, we have three orbitals. 4, 5, fifth period, 5 orbitals, sixth period, 6 orbitals, and the maximum number of orbitals that we can have is 7. Don't worry about this stuff down here. These elements, if placed in here correctly, should be squished into here, but that would make the periodic table way too long, so they just put this stuff down here. You're never going to use anything with these elements anyway. Most of them are radioactive and they've been created in a laboratory. So just to refresh, periods go across, and elements in the same period have the same number of orbitals. As you go from left to right, the atomic number is increasing by 1, which means the number of protons is increasing by 1. Now on the left side of the periodic table, we have metals. An example of some typical metals that you've seen before, we have copper, nickel, zinc, silver, gold, iron, cobalt. These are all metals. Some of the physical characteristics are they are malleable, which means they can be bent without breaking. They also conduct electricity, they conduct heat, and they also have luster. Well, what is luster? Luster is basically shininess. If you look at this clipboard, this is metal, this is made up of nonmetals. If I bend this, it won't break. If I bend this, it would break. This is shiny, this is not shiny. This conducts electricity, because it's a metal, and this does not conduct electricity. Now, metals like to lose electrons, and nonmetals are on the right side, they like to gain electrons. But we have this little staircase right here. And this little staircase contains what is called metalloids. And metalloids have characteristics of both metals and nonmetals. If you look on your periodic table, you're going to see a little staircase like this. Every element that touches this staircase is a metalloid, with one exception. Aluminum is a metal. So we have boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. These are all metalloids. This is the only metal. All of these elements are nonmetals. Now some characteristics of nonmetals. They do not conduct electricity. They do not conduct heat. They are the opposite of malleable, which means they are brittle. In other words, if I bend this, it's going to break. So Mendeleev organized the periodic table into vertical columns, and he called these vertical columns groups. And originally we had 1, 2, 3, 4, 5, 6, 7, 8 groups. But then we've since discovered a lot of transition metals that have been placed into the periodic table. We'll talk about these as the year progresses. But the groups are organized according to the number of valence electrons. Look over here in group 1. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Groups 3 through 12 have typically 1, 2, or 3 valence electrons. And then as we go, group 13 has 3, 14 has 4, 15 has 5, and so on up to 18 with 8 valence electrons. These 8 valence electrons makes them non-reactive. They like to neither lose nor gain electrons because they have a fully satisfied valence. With the exception of helium, helium can only have 2 electrons. Now, one other thing about this periodic table that's a little bit confusing. This guy right here. Hydrogen was placed on the left side of the periodic table because it only has 1 valence electron. So it has that in common with group 1. However, hydrogen is a nonmetal. Lithium to francium are all metals. Okay? Don't forget that. For your practice, the directions are right there. You're going to use a color pencil and you are going to color the nonmetals are going to be one color. The metalloids are going to be another color. And you're going to color all the metals a third color. These down here are going to remain uncolored. In addition to doing this, I want you to provide me with a key somewhere on your periodic table that is color coordinated. I will not give you credit on this video until this is completed in your periodic table. Peace.